Section 3.2, properties of functions graph. So in this section we have to deal with the graph of functions, and from the graph we need to find out different information about that function. uh, so first of all, we're going to find out the intercepts, x-intercepts and y-intercept, and by looking the graph we're going to find out the domain and range of that graph. And then just by looking the graph we need to find out either that graph is increasing, decreasing, or constant, and eventually we're going to find out a relative maximum and relative minimum value of a function using the graph. So intercepts means whenever you have a graph, let's say you have a graph of a function. Let's say we have a graph of a function in the coordinate system like this. Then this graph is, if you look at the graph, this graph is intersecting with the x-axis at these 3 points. Let's say that these 3 points are A, B, and C for the x value. Then these 3 points are called x-intercept. And this graph, you can see that the graph is intersecting with the y-axis at this point, let's say D. Then that point D is called the y-intercept. Okay. So the y-intercept means the y-coordinate of the point where the graph crosses or touches the y-axis, and the x-intercept means the x-coordinate of the points where the graph crosses or touches the x-axis. Um, if we are dealing with the graph of a function, then we might have more than one x-intercept. Theoretically, you can say that there might be infinitely many x-intercepts. So remember, as you notice here, the the x-intercept means a point of intersection of the graph with the x-axis. That means the value of the function at those points are 0. So because the y value is 0, y value means the value of the function. So whenever we try to find out the x-intercept of a function, then we just always equate f of x equal to 0 and solve for x. If we are dealing with the function, then the maximum, we could have one, at most we could have one y-intercept. There is no more than one y-intercept if we are dealing with the graph of a function. To find out the y-intercept, we just have to calculate the value of the function at 0. Let's look at one example here. Here is a function f of x, and now we want to find out the x-intercept. For x-intercept, as we know, the function has to be 0, and then that means the function is x squared plus x minus 2 equals 0. We need to solve this equation for x. So we can use the different ways of solving quadratic equation, like factoring, formula, quadratic formula. I'm going to use factoring method here. So -2, +1 are the two factors of -2, such that, or yeah, it's just opposite, +2 and -1, because +2 and -1 gives you the +1. So if we try to solve these two factors, it will give us two different options, -2 and +1. So these are the two x-intercept for this function. Okay, and for the y-intercept, we just need to find out the value of f0, meaning whenever you see x here in the function, just replace that by 0. So that will be 0 plus 0 minus 2, which is -2. Okay, so the meaning is, if we try to plot a graph for this function, this graph of the function is going to intersect with the x-axis at point -2 and at 1. And similarly, the graph is going to intersect with the y-axis at point -2 on the y-axis. Okay, so at point 0 comma -2, and here these are -2 comma 0 and 1 comma 0. These are the 2 points. Okay, for finding the domain and range of function, we look at on x-axis and then y-axis. So domain means all the possible x values for that graph. So as you can see that this graph is going from left to right, and down to up, or so to find out the domain, when you walk from left to right, you know uh, on this graph, from what value of x-axis to what value of x-axis we would go, that is the domain. So in this graph, the graph is going from value of x equal a to x equal b. So the domain of this function is from a to b, including a and b. So the domain would be from a to b. And similarly, the range means when you walk on y-axis from bottom to top, it starts from c is the lowest value, and it goes up to d is the highest value, so it's a c to d. So the domain is from a to b, and range is from c to d. So the domain is the set of all input values, which means x values, and then range is set of all output values, which means y values. So let's look at one example here. Look at the graph and try to find out the domain. Remember, to find out the domain, we just look at on x-axis. So this graph has starting point x equal -5, and this graph goes up to x equal +4. So the domain is including -5, that's why we use the bracket, comma, it goes up to +4, including +4. So domain means there is a point on this graph for any x values starting from -5 to +4. And remember, there are infinite points in between those two numbers, including -5 and +4. So that's the domain. And for the range, you look at the y-axis. From what value, the minimum value, to what value, the maximum value, the graph is, you can see the graph. So as you can see that this point is the lowest point when you go from when you walk from bottom to top, and then this point is the highest point. So we have to focus on the y coordinate. Here the y coordinate is 0, including that point, that's why you have to use the bracket, comma, it goes to that point which is 6. You have to focus on the y coordinate. So for the domain, you have to focus on the x coordinate, which is the lowest one up to the upper one, including everything. If there is something missing, you don't include that. But here there is nothing missing. There is no gapping. And range is the y value. From what y values to what y values the graph is expanding, and that is your range. Sometime, by just looking the graph, we can find out, not sometime, if you have a graph, you can always find out either that graph is increasing, decreasing, or constant. So for increasing, the graph should get graph should go higher and higher when you move from left to right. Decreasing means graph should go lower and lower when you move from left to right. And then constant means it just goes it always gives you the same value. So a function f is said to be increasing on an open interval if the value of a function gets larger as x gets larger, and then function is called decreasing if the value of the f of x gets smaller as x gets larger, and then graph is constant if the value doesn't change. Let's see one example here. This is the graph. When we move from left to right, when you go from left to right, the graph is going up, 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 up to this point. So that means up to -10, which is this one, -10. From here to here, -10, the graph is going up. It's increasing. And at this point, now graph starts going down up to here, which is, for that, you have to find out the x value. So from -10 to +10, the graph is going down. And now starting from +10, now again the graph is going up. So the graph is increasing from -infinity to -10, and from 10 to 17. So that is the last point. From 10 to 17, now again the graph is increasing. But we don't write our answer like this. We have to use union sign. So we can say, okay, this graph is increasing on this interval and on this interval, so we have to combine them. And by looking the graph, you can see that the graph is decreasing from -10 to +10. So here we're talking about the x values, okay, on the x-axis. So graph is increasing from decreasing from -10 to +10, okay. And then constant there is nowhere the graph is constant. So the answer is nowhere. Nowhere. The graph is not constant actually. Okay, we also have to find out maximum, actually relative maximum, and minimum, the relative minimum of the function value. If you have a graph and at some point to the left of that point the graph is increasing, and from that after that point the graph is decreasing, then that point is called relative maximum point. As you can see that the graph is increasing up to this point, and after this point the graph is going down. So this is called relative maximum. Okay, when a function changes from increasing to decreasing, as you can see that it's increasing up to this point, and right after that point the graph is decreasing. The function has relative maximum at that point, and then that maximum value is actually the y coordinate of that point. Remember, this point is c comma f of c. So this point is called the point where the function has a relative maximum value, and the y coordinate of that point is actually the relative maximum value. Okay, similarly, if the function is going down and after some point the function starts growing, then that point is called relative minimum. One example, if we zoom in this graph here, we need to find out where the graph is increasing, where the graph has a relative maximum or relative minimum. As you can see that, to the left of -7 the graph is increasing, and right after the -7 the graph is decreasing. So this -7 comma 6 is relative maximum point. This is the point where you have relative maximum. And what is the value? What is the value of relative maximum here? The value comes from the y coordinate. Similarly, before this point, which is uh, -1 comma -3, before this point the graph is down, and after this point the graph is up. So this is the point where you get relative minimum, and then relative minimum, the value relative minimum is the y coordinate, which is -3.